Hi, I'm Maggie Fires, and I will be presenting on Chapter 20, the lymphatic system and lymphoid organs and tissues. About the lymphatic system. The lymphatic system returns leaked fluids and blood from the blood vessels back into the bloodstream. It includes three main parts: a network of lymphatic vessels, the lymph fluid inside them, and lymph nodes that filter and cleanse the lymph. Lymph organs and tissues are important for defending the body against disease. Key organs include the spleen, thymus, tonsils, lymph nodes, and other scattered lymphoid tissues. The lymph nodes serve a central role in both the lymphoid organs and the lymphatic system. Lymphatic vessel structure and flow. Lymphatic vessels form a one-way system moving fluid toward the heart. The right lymphatic duct drains the right upper body, and the thoracic duct drains the rest. Through the ducts, lymph is returned to the bloodstream at the junction of the internal jugular and the subclavian veins. Role of lymphatic capillaries. Lymphatic capillaries are the starting point of the lymphatic system, collecting fluid from tissues. Their thin walls are made of overlapping endothelial cells, and they create flap-like openings, allowing easy entry of fluid. Collagen fibers anchor the capillaries in place, and so they stay open even when tissue pressure changes. These one-way flaps act as valves. They open when pressure outside is higher and close when pressure inside increases, preventing backflow. Lymphatic capillaries play a key role by taking in proteins, cellular debris, pathogens, and cancer cells from the surrounding tissue, helping clean and return fluid back to the bloodstream. Specialized capillaries in large vessels. Lacteals are specialized lymphatic capillaries in the intestines, and they absorb dietary fat. The fatty lymph they carry is called chyle. Lymph flows from capillaries to collecting vessels, trunks, and then ducts. The lymphatic collecting vessels have thinner walls and more valves than veins. Lymphatic trunks. Lymphatic trunks drain lymph from large regions of the body like the limbs, thorax, and abdomen, and they channel it into two main ducts. The right lymphatic duct drains the right arm and right side of the head and chest, while the thoracic duct drains lymph from the left side of the head, chest, left arm, and the entire abdomen and lower limbs. These ducts return lymph to the bloodstream at the junction of the internal jugular and the subclavian veins in the neck. Lymphoid cells include immune cells found in lymphoid tissues and support cells that maintain the tissue structure. Lymphocytes are the main immune cells, and they are the primary defenders in the immune system. T lymphocytes, or T cells, manage immune responses and directly attack infected or abnormal cells. B lymphocytes, or B cells, produce plasma cells, which secrete antibodies that help identify antigens for destruction. Macrophages, dendritic cells, and reticular cells support immunity by engulfing invaders, presenting antigens, and forming tissue framework. Lymphoid tissue. Lymphoid tissue houses lymphocytes and allows them to become activated and multiply. Most of the lymphoid tissue consists of reticular connective tissue, where lymphocytes move through and temporarily reside. Lymphoid tissue can appear in two different forms: diffuse tissue, which has loose cell arrangements, and lymphoid follicles, that has dense spherical structure of B cells. Some follicles are organized into larger structures like Peyer's patches and the appendix, which are important for gut immunity. Lymphoid organs. Lymphoid organs are classified as primary or secondary based on their immune function. Primary lymphoid organs are where lymphocytes mature: T cells in the thymus and B cells in the red bone marrow. Secondary lymphoid organs are where mature lymphocytes first encounter antigens and become activated. These include lymph nodes, spleen, tonsils, Peyer's patches, and the appendix. Only the lymph nodes filter lymph. Other secondary organs monitor antigens from food, air, or the bloodstream, but do not cleanse the lymph. Here's some functions of lymph nodes. Lymph nodes are the most important secondary lymphoid organ and they are found clustered along lymphatic vessels. Though there are hundreds of nodes in the body, they are usually hidden within connective tissue. Large visible clusters of lymph nodes are located near the surface of the inguinal, axillary, and cervical regions. Lymph nodes filter the lymph, with macrophages removing and destroying microorganisms and debris to prevent from reaching the bloodstream. They also serve as sites where lymphocytes encounter antigens and become activated to initiate immune responses. The structure of a lymph node. Most lymph nodes are short and round and enclosed by a dense, fibrous capsule. Connective tissue strands called trabeculae extend inward from the capsule, dividing the node into compartments. The cortex contains B-cell rich follicles and deeper T-cell areas along with dendritic cells that help activate lymphocytes. The medulla contains cords of B cells and T cells and large sinuses where macrophages remove foreign particles from the lymph. Circulation in lymph nodes. Lymph enters a lymph node through multiple afferent vessels on its convex surface. It flows through the subcapsular sinus and then through smaller sinuses in the cortex and medulla. Lymph exits the node through fewer efferent vessels at the hilum on the concave side. The slower flow of lymph due to fewer exit vessels gives immune cells more time to filter pathogens and respond. Lymph typically passes through several nodes before returning to the blood, ensuring that it is thoroughly clean. The structure and function of the spleen. The spleen is the largest lymphoid organ, located in the upper left abdomen beneath the diaphragm. It's supplied by the splenic artery and vein, which enter and exit through the hilum. The spleen provides a site for lymphocyte activation and immune response. Components of spleen tissue. The spleen is surrounded by a fibrous capsule and it contains an inward projecting trabeculae. White pulp surrounds the splenic arteries and contains lymphocytes that carry out immune functions, while red pulp is responsible for breaking down old red blood cells and filtering bloodborne pathogens. Together, white and red pulp enable the spleen to defend the body and maintain healthy blood composition. Mucosa-associated lymphoid tissue, or MALT. MALT is a group of lymphoid tissues located in the mucous membranes throughout the body. It helps protect the body from pathogens entering through exposed surfaces. So major components of MALT include the tonsils, Peyer's patches, and the appendix. Smaller MALT tissues are also found in other areas of the digestive tract and in the mucosa of the respiratory and genitourinary organs. MALT serves as the body's frontline immune defense at common pathogen entry points. Tonsils. The tonsils are a ring of lymphoid tissue around the entrance of your throat, and there are 4 different types: the palatine, lingual, pharyngeal, and tubal. Tonsils trap and destroy pathogens from inhaled air or ingested food using crypts that draw bacteria into the lymphoid tissue. Tonsil tissue contains germinal centers and scattered lymphocytes, but is not fully encapsulated, which allows easy interaction with pathogens. Peyer's patches and the appendix. Peyer's patches are clusters of lymphoid follicles, and they are located in the wall of the distal small intestine. They are structurally similar to tonsils, but they monitor intestinal bacteria and prevent pathogens from breaching the intestinal lining. The appendix is a narrow tube-shaped extension off the large intestine with a high concentration of lymphoid follicles. Both the appendix and Peyer's patches are positioned to stop bacteria and generate memory lymphocytes. Thymus and T-cell maturation. The thymus is a bilobed organ located in the upper thorax, where T-cell lymphocyte precursors mature into T cells. It is not a part of the MALT system as it's not associated with mucous membranes. It's most active during childhood but is replaced over time by tissue. However, it does continue to produce T cells. Unlike secondary lymphoid organs, the thymus has no follicles and does not fight antigens directly, and its stroma is made up of epithelial cells, not reticular fibers. A blood-thymus barrier prevents foreign antigens from entering.